So in the past few lessons, we've been talking about volume and talking about creating layers, looking at the length, the width, the height. Today, we're going to talk about those formulas that we've already kind of been introduced to in lesson 1.9. Our objective is to be able to use a formula to find the volume of a rectangular prism and also to understand those concepts of volume to be able to solve problems like the one that is here. So today's lesson, we're going to learn another way to find the volumes of rectangular prisms. In the past, one of the strategies we used was to determine volume of a prism involving finding the number of cubes in a single layer and then multiplying that number by the total of layers possible. So see below in the purple, it says volume equals number of cubes in one layer times that number of layers. Well, that connects to this, okay? So we have volume, which was V. The base was a capital B, and if you watched lesson 1.8, you saw that and you learned that. And then H was height. So we, in a previous lesson, had cut out little shapes like this. So looking at this, we would want to find the area of the base and then measure its height. And after you've applied that formula, we could confirm it by packing. We're not going to pack today. We're simply going to use that formula. So when we take a look at this, I'm only going to look at the base part, and I'm going to outline that for you. This right here was the base of rectangular prism F. So I'm going to find the area of that. And I go 1, 2, 3, 4 by 1, 2, 3, 4. So I know a 4 by 4 would be 16. Our base would be 16 squared units. And then I'm going to look and see how tall this was. And I know, I'll use a different color for you. I know that this right here was the wall of the prism. And so I know the height would be 1, 2. We would have 2 layers of 16 cubes. So we would end up taking 16 times 2 layers, giving us a grand total of 32 cubic squares or cubic units with the volume of 32 cubic units. So again, practicing that, we see that you could have the formula of V equals capital B times height. We would want that height there. So I'm going to fill that in. We know we would want the height. So what we'd simply do is you just go through and you multiply these. I want to remind you that capital B, this column right here, is the area of the base. So that would be your first step when using this formula. What is the area of a base, and then how tall is it? So we know this one, if the area of the base was 10 and there were 8 rows high, our volume would be 80. This one, we would have 4 and 5 rows. We would have 20. And then finally 30 and 7 rows, we would have 210. Now, these are not complete answers. And the reason is that I forgot to put a label. So when I'm looking at this, I see the first one was 80 units. So I'm simply going to say 80 units. And I apologize for the handwriting here on the computer. But it would be 80 units cubed. So we have that exponent of 3. Same thing for the next one, but this time I might say 20, and I might write cubic units. Again, sorry for the uneven handwriting. Now the third one's a little different because I see they're not saying just units, they're actually saying centimeters. So I could write 210, and then I'm going to write centimeters, and then put that exponent of a 3. So it's 210 cubic centimeters or 210 centimeters cubed. Again, That was us using the area of the base and then multiplying it by height. So that's giving us the layers. The formula we just used was volume equals capital B times, they keep leaving off our height there, our height. And another formula we know is length times width times, again, that height there. So the relationship between these two, that's the question. What is the relationship? I notice that in height, I have in the same color, the teal here. What about this capital B? What does it connect to in that second formula? Well, if we look at it, let's change this color so we can. These are the two things that are connected here. And I know that area of a base equals length times width. And that's where we get that. That's how these two formulas are the exact same. It's still length times width times height. Okay, so what you can do is you can actually use rulers to measure the length, width, and height of prisms E and F if you have those, and check those out. Try working with those. What I have here is rectangular prism E, okay? And I know that what they've done here is each little cube, each little square on here is representative of a centimeter, a cubic centimeter. So I'm going to fill this in. If you have the prism E still, you can cut that out and then use your ruler to measure. And what I'm going to do is I'm going to simply look. We see here that we have 1, 2, 3, 4. Okay. It is 4 centimeters long. Then it is 1, 2, 3 centimeters wide. And then tall, like we talked before, I know that it goes 1, 2, 3. That side actually creates the side wall. So it is 3 centimeters tall, allowing us to create our formula of 4 times 3 times 3. Well, I know 4 times 3 is 12, and then 12 times 3 is 36. So we've used several different ways to find the volume of rectangular prisms. The cutouts, we have packed them with cubes, as seen in a previous video. And now we are finding the area of the base, so finding the layers and how tall they are. And this time, the length times width times height all would give us the same answer of 36 cubic units, or 36 with this one, centimeters cubed. So now it's your turn. I want you to turn to page 25 in your math journal. Pause your video here and then come back and check your work. Okay, on numbers 1 and 2, you were supposed to use the formula to find the volume of each prism. Remember, you've got length times width times height, or area of base times height. For number 1, the length times width times height would be your easiest one. And for 2, the area of the base times height would be your best choices. Let's go and look. 1 should have been 160 units cubed, and 2 was 80 units cubed. And you could see that by doing number 1, 8 times 5 times 4, giving us 160. And number 2, you would have found 20 cubes on the base and 4 rows. 20 times 4 equals 8. On 3 and 4, this time they didn't give us the cubes inside. They gave us measurements. So you could have used either formula to help you out, length times width times height, or you could have found the area of the bases. So for number 3, we see 6, 3, and 4. So you could have done 3 times 4 times 6. And on number 4, you could have done 6 times 3 times 5. Let's check those answers now. You should have completed them already. And for number 3, you can see 72 centimeters cubed. And number 4, 90 units cubed. Paying attention to those labels, guys. On number 3, we see they were centimeters, and on number 4, they simply said units. And then number 5 and 6. So number 5 is part of it, and 6 was the try this. It's kind of an extension activity. On number 5, they give us the area of the base. So all that blue shaded area, 25 centimeters squared, and we see that it was 2 centimeters high. So you should have taken 25 times 2, and hopefully you'll get 50 centimeters cubed. And then number 6, the try this. This is a rectangular prism, has a volume of 36 units. Write 2 different possible sets of dimensions for the prism. So this is kind of like whatever you come up with needs to have a volume of 36 cubic units. Let's take a look at those answers. So again, like I said, number 5 should have been 50 centimeters cubed. Again, you had capital B times H. And some examples, some sample answers for number 6. You could have had 2 times 9 times 2 because you want to get to 36. So we know 2 times 9 is 18 times 2. And you could have also done 3 times 3 times 4. Maybe you had something different because, again, these are sample answers. No matter what, the 3 numbers multiplied together needs to equal 36. Again, we learned about those volumes formulas today. Volume equals length times width times height. Volume also equals the area of the base times height. And hopefully you will able to answer number 3 and get that correctly, because that was our objective of learning that it was 72 cubic centimeters.